1.5 degrees, 2 degrees. We hear these numbers all the time, right? But what do they actually mean? I mean, they sound so small, almost insignificant. But these aren't just numbers. They're basically the scientific guardrails for the future of our planet. So in this explainer, we're going to break down exactly what they mean and why that tiny half-degree difference is one of the most critical issues of our time. So that's the big question, isn't it? How much warming is really too much? It's so easy to dismiss. A 1 or 2 degree change, the temperature outside my window can swing by 20 degrees in a single day. But here's the thing. For the entire planet's climate system, well, those small numbers have massive, world-altering consequences. And look, this isn't some far-off someday problem. It's a right-now reality. As of today, we've already warmed the Earth by roughly 1.4 degrees Celsius. We are living in a world shaped by that heat as we speak. And yeah, we're getting dangerously close to the limits scientists have been warning us about for decades. Okay, so to get to the bottom of this, we're going to break it down into 5 key parts. First up, we'll look at that crucial half-degree difference. Then we'll dive into the real-world impacts. We'll talk about the dreaded point of no return. We'll check out the economic bottom line. And finally, we'll talk about our own agency in this warming world. So, Section 1, the half-degree difference. This whole conversation really comes from the 2015 Paris Agreement. That's where world leaders agreed to keep warming well below 2 degrees Celsius while really pushing to limit it to just 1.5. So why those specific numbers? Well, it's because the science showed that this is where the path splits, between a future with serious but manageable risks and one with catastrophic runaway change. And here's the really crucial point. The difference isn't a gentle slope. The UN's Intergovernmental Panel on Climate Change, the IPCC, basically the world's leading authority on this stuff, found a stark contrast between the two. Think of 1.5 degrees as a world with serious challenges, for sure, but ones we can probably still manage. 2 degrees, though, that's the danger zone. It's a world where a lot of those impacts roughly double, pushing us into a state of dramatically higher risk. Which leads us right into Section 2, degrees of impact. This is where we get into the nitty-gritty, the real-world stuff. What does that jump from 1.5 to 2 degrees actually look like for the planet and, for us? Okay, just look at the effect on biodiversity. At 1.5 degrees of warming, an estimated 14% of species are facing a high risk of extinction. Now, that's already devastating. But at 2 degrees, that number jumps to nearly 1 in 5 species on Earth. That single half-degree difference pushes thousands upon thousands of additional plants and animals right to the absolute brink. And if you want a perfect, heartbreaking illustration of an ecosystem on the edge, look no further than coral reefs. At 1.5 degrees, we stand to lose between 70 and 90% of them. Tragic. But some might just survive. But at 2 degrees, we lose pretty much all of them, over 99%. That half a degree is the difference between a deeply wounded ecosystem and a completely annihilated one. And this isn't just about nature out there. It's about us. Right here in southern Africa, that extra heat doubles the number of extreme heat days. Again. In the Mediterranean, the area burned by wildfires just jumps dramatically. And at the same time, rising seas mean millions more people around the globe become exposed to coastal flooding. You see, every impact just feeds the next. That half a degree means more danger, more damage, and more displacement. Okay, and this brings us to a really critical, kind of scary concept. Section 3, the point of no return. This is the scientific reason why that 2 degree number is considered so dangerous. It's not just about things getting worse. It's about crossing thresholds from which we just can't come back. So what exactly is a climate tipping point? Well, it's a threshold. And once you cross it, a system doesn't just get a little worse, it fundamentally changes, kicking off a chain reaction that just feeds itself and becomes, for all practical purposes, irreversible. Not just in our lifetime, but for many, many lifetimes to come. It's like pushing a giant boulder right to the edge of a cliff. Once it goes over the side, there's no way you're pulling it back up. And many of Earth's most vital systems are getting dangerously close to these tipping points. We're talking about the massive ice sheets in Greenland and Antarctica. If they go, they could lock in meters of sea level rise for centuries. We're talking about the huge ocean currents that regulate our weather, like the one in the Atlantic, whose collapse could plunge Europe into a deep freeze. And we're talking about entire ecosystems, like the Amazon rainforest, risking a total collapse into a dry savanna. All right, let's pivot and talk about something everyone understands: money. In Section 4, we're looking at the economic bottom line.
what are the financial consequences of all this warming, and does it really make economic sense to act?
Now, to be fair, it's true that there are some isolated, localized upsides. Higher CO2 can act as a fertilizer for certain crops, and some colder northern regions might benefit from longer growing seasons. But let's be crystal clear about this. These potential benefits are small, they are localized, and they are absolutely dwarfed by the overwhelming economic damage.
Because the overall economic picture is, well, it's staggering. Recent research suggests that for every single degree Celsius of warming, the world can expect to lose about 12% of its GDP. 12%! Just let that number sink in for a second.
And to put that 12% figure into perspective, it's been described as a depression-level impact, repeated every single year. This isn't just a line on a chart. This is crops failing from drought and heat. It's our infrastructure, roads, grids, ports being destroyed by storms and floods. It's lost productivity because it's just too hot for people to work. Suddenly, that whole debate over the cost of transitioning to clean energy gets turned on its head. The real question isn't can we afford to act? It's can we possibly afford not to?
So, where does all this data leave us? I know, it can feel overwhelming. And that brings us to our final section, agency in a warming world. It's about moving beyond the stark facts to find a clear-eyed, realistic path forward.
So where do we go from here? Well, the most useful path forward is what you might call climate realism. Look, it's not denial. The science is undeniable. And it's not doom. Giving up is just not an option. It's about looking squarely at the data, understanding the stakes, and then acting with clear-eyed determination. So what does this path look like? Well, first, we have to acknowledge reality. We're at 1.4 degrees and the impacts are here. But second, we have to reject doom. Innovation is accelerating. Just this year, renewables generated more electricity than coal globally for the first time ever. This means focusing on the thresholds, because every single tenth of a degree we manage to avoid matters immensely. And finally, it means embracing our own agency. As climate scientist Tim Lenton puts it, so simply and so powerfully, we still have some agency. We are not just passive passengers on this ride. We're still at the wheel, and the choices we make starting right now will determine the destination. Ultimately, the science is crystal clear. The difference between a manageable future and a catastrophic one is measured in fractions of a degree. Every single tenth of a degree we avoid saves ecosystems, economies, and lives. And that really leaves us with one final crucial question to ask ourselves. What will our fraction of a degree be worth?